Hi, in this video we're going to do a screen tour and overview of the JTAG Circuit Test software. And to get started, we'll take a quick look at the various sections of the screen. Over on the left, we have three panels. The controllers panel will show you any JTAG controllers that you have, USB controllers that you have connected. In this case, we have one controller that has two JTAG channels. So you have information about the channels. If you have an application, you can match a JTAG chain, for example, to a particular port on your controller. You can have as many controllers as you like for a particular application. There's no limit there. You can do things such as set the TCK rate, the clock rate. The default is 9 megahertz. If you don't have a connection, you should click None. You can also wiggle particular tap pins if you like. And okay, so moving on. Another part is solutions. This panel will show you a list of all of the projects that you have. It will show you the latest ones that have been opened, so you can click on those and it will open them directly. The circuit we'll take a look at, we'll open a test, a netlist-based test, and we'll look at the circuit designations. Up on the upper left is the application button. So if you want to do a new project, open a project, this is where you would go, and then once you have a project open, a project folder open, you can select particular tests or add tests using these controls. You can save and close from this menu. This panel will show you a list of pins when you're in the circuit mode and you have components with an application open. We'll show a list of pins. We'll take a look at that in a moment. The ribbon menu shows the different functions that you can do. For example, on the home function, you can look at help. Oops. Let me get the help screen over here. You can look at that. I'll close that up. You can take a look at your license information, what portions of JTAG Circuit Test you have enabled, the build number. These other items will select, when you select them here, for example, JTAG setup, when we're setting up a new project or editing an existing project, we'll do it here. And we'll take a look at that. Running projects, running tests, debugging tests, we can do in JTAG Ops. Script is for writing scripts to control, in particular, non-JTAG components. Tools, we can do a number of things. We can check the syntax on BSDL files. And again, there's the help, access to online help. So in order to demonstrate some of these things, let's first just show what would happen if we wanted to do a new project. What you would do is browse to a folder that contains your BSDL file. So we have one here, and we've already opened this in a previous tutorial, but this procedure is simply you select the folder. It will show you a list of the BSDL files. That's boundary scan description language, and those files describe the JTAG implementation for each boundary scan device. If we wanted to do a net list, we would use the optional net list, and we'll do that with another file, but for now we'll just click OK. And from here, what you would do is take this list of BSDL files in that project folder, and you can drag and drop these into this column, JTAG Logics, which is going to define, we're going to use this to define a JTAG chain. So you could do it that way, or you can just click Auto Detect, and this will show you, as long as you have the hardware, it will show you the list test data in to test data out of these BSDL files. So these are the 4 JTAG chips on our test board. These are the types of chips and the BSDL files representing them. In order to get the chain defined, we can just use this button to move the device list over to this column. And in this column, you can go with these default reference designators for the circuit locations on your board, or if you know what the circuit locations actually are, you can just edit in place. So this is our JTAG chain. By default, it's called chain A, but you might have multiple chains, and you just right-click for a menu, and you can increment and decrement the chain numbers. So as you add devices and chains, they would show up here. Then, once we have this defined, we simply click OK to accept it. And the software now puts that JTAG model over in this circuit area, so you can see a list. If you click on a device, you'll see all of the pins in that device list. So you can do that. Here you have some chain options if you want. You can define things like do a test access port, a test. You can show instruction capture, bypass, ID code. You can elect to measure the boundary register length to make sure that you have the right number of cells in your JTAG chain. Now that we have defined this, we can go back in here and make sure that our adapter file for the controller matching up to the devices on your board is correct, and we just click Save That. So here's our circuit. So once you've done that, now we were in the setup area when we defined the JTAG chain. Now we can, we're ready to go to JTAG Ops, where we actually run some tests and check out connections between pins and devices. At this point, we also can create a tap test and run the tap test, bearing in mind that the boundary scan implementation JTAG on your board is actually a test instrument, even though it's embedded in your board in the JTAG devices. But we want to make sure that that's good. So we're checking ID codes, we're checking the boundary register length. We expected 2,295 cells, measured 2,295 cells. And that's good. If we wanted to, when we run the tests, we could go in to any particular device. We could change the opcode. The default will be X test, but if we wanted to, we could put it in bypass and do things of that nature. When you aren't running script programs, let's say you're testing a memory device and you want to go as fast as possible, for the devices that are not interacting with the memory, it would be a good move to put those devices in bypass. So instead of going through the entire boundary register for that particular device, we just go through the bypass register. So now we are ready to run a test, and all pins will run a test on the device. We have some failures. What you can do is you can debug here, and you can check out individual failures. You can do pin wiggling. For example, the software broadcast a signal on all of the I/O pins on the board, and then look to see what received that signal. So in this case, it was saying pin R1 is connected to pin P1, and then it's asking, do you really want to connect that? You could say, well, I'm not so sure. It may be connected through some resistors on the board. Let me check it out. So you select R1, and then that will bring up R1 in your net list, and you can then wiggle a pin, see if they switch together. In this case, they do. And then you could say, connect to this net. Okay, so that would then pass that. So let's run the test again, and we fixed one. But the easy way to do it is just to say, learn trace results. And then once we do that, okay, so that's the way that works. And you can introduce, for debug, you can introduce faults on your board. I could do that, for example. For example, I just flipped one of the switches on the board, and that changed the configuration. So we have a failure at this pin T7, which, since we have the schematic, we're not using the net list, but we can see that this pin is indeed connected to the switch, and we've changed the connectivity. So you do get diagnostics. So even with just a BSDL-based application, you will get a test and diagnostic. So it's a pretty powerful technique to find and debug boards, prototype boards, or whatever you have. There are some other things we can do on the board. I'm going to rerun this. Okay, so I just flip the switch back, rerun it, and it passes. You can monitor signal activity on the board. So this is monitoring signal activity in application mode. So if you want to do that and watch particular pins, or just which pins are switching on the board, it's a very slow logic analyzer in effect. But that's sometimes useful for debug purposes to see what's switching. I didn't mention, but something that should be done in setting up a test is looking for your power and ground nets and identifying them. For example, we want to make sure if there are any boundary scan pins connected to ground nets, we don't want to be driving them. So we tell the software, these are the ground nets. Say here are some power nets. So that is a good thing to do. In addition, you may know of certain pins that, I'm going to put this back in logic list. And for these things, you can order these things by by pin count or alphanumerically. You can list things by logics or nets. So back in logics, let's say you pick a device. One of the things you can do is, for any given pin, if you want, you can put constraints on it to hold an output, for example, low, or drive it high throughout a test. So statically it would hold that value. A sense, turn outputs on or off. So you can set these constraints just by clicking on a pin and setting the constraints as you'd like. You can also select particular pins, and instead of testing the whole board, just test the one pin. For example, on device U3 pin 8, it's when we run the test, it's showing that it's connected to U3 pins 24 and 20, and that is indeed a correct connection on the board. It will also show you clock activity, background activity that's going on the board, nets that are held low or high, it will list those. So that's, when you go, the home didn't cover this, but the home page has a list of tutorials. So you click on these for particular tutorials. So let's see what else we have. If you want to close an application up, close it like so. If you want to, let's say we want to reopen the one that we just did. You reopen it. Or you could, let's say we close it. You can go to the Solutions tab, and it will show you the last folder and open the last test that you ran. So if you wanted to reopen, this is kind of a more efficient, direct way of opening your last test. You can always look at your last, even if the board's not connected, you could look at a list of items. Also in the Solutions panel, if you want to, there's a viewer. So if, let's say you wanted to look at a BSDL file, you can do that. If you wanted to, you can go to Tools and you can check the syntax on a BSDL file. It's simple enough. And it will show you any syntax errors. For example, in IEEE 1149.1 or 6, 2013 documents, standards, you can do that. So let's close this. Just for thoroughness, let's open a project that had a net list. This one. Now, when you have a net list, what you'll see is a list of all of the components on your board. And having the net list is very handy because it gives you more thorough diagnostic information, and it lets you browse through it, show where signal activity is occurring on your board. And if you're doing a script test, it gives you access to non-script devices like memory chips and resistor networks and the like. Okay, so here, let's say we open this. We have a test called interconnect. You can run the interconnect test, and it's passing. This is a pass-fail. I think I forgot to mention that. That's pass-fail. So that's working. And I just flipped the switch again like we did before, and again the same pin. Now that we have netlist information, we know it was dip switch 8 on this net, and here it is. And if we click on it, that will bring up some context. So now that will show us the pin in the net. So this is connected to resistor pack 6, pin 10, and switch 4, pin 8, switch 8. So if we then click on the resistor pack, it will show us what that's connected to, and you can go back and forth and browse on different pins. When you click on a pin over in the logics list, to open a logic, and click on one of its pins, it will then bring you to that pin and net over in this pins list. In the pins list, let's go, we click on here. Again, we can wiggle these pins. Now that's stuck. You can wiggle those pins. We can order the pins here by alphanumerically, or we can sort them by net names. This is sometimes helpful if you want to look for particular signals. For example, here are the signals on the SRAM, and you might want to pick a signal, let's say an enable signal, for example. Not sure exactly where it is, but let's say you could pick any pin and use the pin constraints to drive let's say there's an enable signal, drive it high. That would keep the SRAM off while, say, you're doing an interconnect test so that you don't get signal contention. So you can do that. Right now, this is showing the last time we ran this test. It ended up with these pins with a logic 1, the up arrow, and these pins with a logic low, the down arrow. We can check to see, just click here. That will show you what kind of pins they are, input outputs, for example. Or if we want to see the value with that pin, we do that. This can be helpful while you're debugging to see what the pins are doing, and also what types of pins you're dealing with. You can go back and forth. If you click on a pin here, it will show you that pin over in the list of pins that you just tested and their values on the board. If you click on a pin in this, likewise, if you click on a pin in this list, it will bring you to that pin in this pins list. So as far as things that you might need to do, you have a whole list of resolutions that you can assign to any pin on any test. Okay, we're going to close up this interconnect test and just show a script test. I'm opening the same project folder. Actually, once you have a project folder open, you can select any of the tests that you like. So we had, in one of the videos, we had done a set LEDs test script. So when you click on the script, you would get the script over here. I have explained the scripting instructions in the script programming video. In order to add a script, you can use this menu, Add Script Program. You can add interconnect tests. So the benefit of using this menu is that, let's say you wanted to add a script program. You could name the script program and then copy the settings. Let's say you've defined settings, guards, power ground, non-populated devices, jumpers, that type of thing for, say, in an interconnect test. You could then leverage that and copy those settings when you're setting up, say, a new script test. And then you could edit the settings again from there if you like. So that's one of the things to bear in mind with script. And again, with script, in order to run a program, you just click on the run, and it will run that script. Here we have an SRAM test. Let's just check the SRAM test. We're going to make sure the adapter to the controller is correct. We only have a chain A, and we're going to set it at 9 megahertz. One of the chips in this application is limited to 10 megahertz, so that's one reason to do this. And then we're going to save this. We're going to run this memory test. So it's going pretty fast. What this memory test is writing data into memory. These pins define the local memory. We have pin group that puts all of these pins in different data buses here, address bus here, and then we manipulate using flow control and function calls to write data to memory location and read data back. So it's a C language like or JavaScript like language with built-in functions, for example, drive low and drive high, drive test, write messages. So there's quite a bit of flexibility and power in this scripting that will allow you to test non-JTAG parts on your board using your boundary scan pins as the test controller. Okay, we're going to wrap up this overview and screen tour right here. Hope you found it useful.